In our next section of limits, we're going to learn how to evaluate limits by reading them off of tables. The function g is defined over the real numbers. This table gives select values of g. What is a reasonable estimate for the limit as x approaches 5? Well, if we take a look, if we approach 5 from the left, that means coming from this side, our y values appear to be approaching 3.68. As we approach 5 from the right, our y values again are approaching 3.68. So it seems that a reasonable limit would be 3.68. Even though at 5 the function is defined as 6.37, the limit as I approach from the left and the right appear to be approaching 3.68. 3 students were given a function f and asked to estimate the limit as x approaches 2. Each student created a table shown below. Which one is the most accurate for approximating the limit? Well, if you take a look at all 3, it looks like table B, they approach 2 coming from the left, they approach 2 coming from the right. I would say that B represents the best approximation for the limit as x approaches 2. Your turn. So I encourage you to pause the video and try to approximate or give the best reason about the limit as x approaches 7. Well, I hope you had time to start this, try this problem. Based on the table, it appears as I approach 7 from the left, my graph is approaching negative 1.9252, and as I approach 7 from the right, it's also approaching a similar value. So I would say a reasonable limit would be negative 1.92. All right, again, pause the video and give this one a try. All right, the table gives a few values of a function. The function is increasing everywhere except at x that's supposed to be equals 5, and the limit as x approaches 5 exists. So what is a reasonable limit for the limit as x approaches 5? Well, there's a couple of key points there. First of all, it says the function is always increasing except at x equals 5. So if we take a look at the table, okay, at 4, it's approximately 4.9. And then at 6, it's 5.6. And so the limit as x approaches 5 has to be somewhere between 4.9 and 5.6 because it is increasing everywhere except at x equals 5. So a reasonable limit would be 5.3 because it falls between 4.9 and 5.6. All right, let's continue with evaluating one-sided limits now off of tables. Okay, so in this particular case, what is a reasonable limit for the limit as x approaches 1 from the left? Okay, 1 from the left means coming from smaller than 1. Okay, well, as I approach 1 coming from the left, it appears that the graph is going to approach a value of 2, because as x gets closer and closer to 1, the y values are getting closer and closer to 2, so this limit would be 2. In our next example, we have a function f defined over the real numbers. What is the limit as x approaches negative 2 from the negative side? Well, as I approach negative 2 from the negative side, the graph seems to be getting larger and larger in the negative direction. So I would assume that this limit is going downhill. It would be approaching negative infinity, or we could say that it is unbounded because it's not really approaching any value. If you ask for the limit as x approaches negative 2 from the right, well, as x gets closer and closer to negative 2 from the right, the graph appears to be getting closer and closer to negative 4. Okay, so that concludes our lesson on reading limits off of tables. So there'll be an assigned handout that you can do. So give that a whirl, and we'll see you at the next lesson.